NFPA 645 Section 4.16.11 states that disconnecting means shall be provided for all CCTV equipment, alarm devices, and other emergency system controls and indicators. NFPA 645 Section 4.16.12 states that disconnecting means shall be provided for all HVAC system controls and power. NFPA 645 Section 4.16.13 is very specific and dictates that the disconnecting means for the pre-action and ANSUL system shall be interlocked with the activation of the emergency response or suppression system. The purpose of these requirements is to ensure that in an emergency situation, specific systems can be quickly and reliably shut down or activated to protect personnel and equipment. Firstly, consider the disconnecting means for CCTV equipment, alarm devices, and other emergency system controls and indicators. This requirement addresses the need to control these systems during an emergency. CCTV cameras might need to be shut down to prevent interference with emergency responders or to protect sensitive information. Alarm devices need to be controllable to prevent false alarms from hindering the response. Other emergency system controls and indicators, such as emergency lighting or communication systems, also need to be manageable to ensure they function correctly during an event. Secondly, examine the disconnecting means for HVAC system controls and power. HVAC systems can contribute to the spread of smoke and fire, making it essential to have a way to shut them down quickly. By disconnecting the power and controls, the HVAC system can be stopped from circulating air and potentially exacerbating the situation. This helps to contain the fire and smoke, improving the safety of occupants and emergency responders. Thirdly, focus on the interlock between the EPO and the pre-action and ANSUL systems. This is the most critical aspect of the requirements discussed. Pre-action systems are fire suppression systems that require a separate detection event, such as smoke or heat detection, before water is released into the sprinkler piping. This prevents accidental water damage in areas where it is not needed. ANSUL systems are specialized fire suppression systems typically used in kitchens and other areas with flammable liquids. These systems use a chemical agent to quickly extinguish fires. The interlock between the EPO, or emergency power off, and these systems ensures that when the EPO is activated, the fire suppression systems are automatically activated as well. This provides an immediate and coordinated response to a fire, minimizing damage and protecting lives. The interlock is crucial because it eliminates the need for manual activation of the fire suppression systems. In a chaotic emergency situation, people may not have the time or ability to manually activate these systems. The automatic activation provided by the interlock ensures that the systems are deployed quickly and effectively, regardless of the circumstances. To further elaborate on the technical aspects, let's consider the design and implementation of these systems. The disconnecting means for the electronic equipment and HVAC systems typically involve circuit breakers or switches that can be easily accessed and operated. These devices should be clearly labeled and located in a readily accessible areas so that authorized personnel can quickly shut down the systems in an emergency. The interlock between the EPO and the fire suppression systems requires a more sophisticated design. It typically involves a relay or control circuit that is triggered by the activation of the EPO. When the EPO is activated, the relay closes, sending a signal to the fire suppression systems to activate. The design of this interlock must be fail-safe, meaning that if any component of the interlock system fails, the fire suppression systems will still activate. This ensures that the systems will function correctly even if there is a malfunction in the control circuitry. In addition to the technical design, it is also important to consider the installation and maintenance of these systems. The installation must be performed by qualified personnel who are familiar with the requirements of NFPA 645 and other relevant codes and standards. The systems must be regularly inspected and tested to ensure that they are functioning correctly. This includes testing the disconnecting means for the electronic equipment and HVAC systems, as well as verifying the proper operation of the interlock between the EPO and the fire suppression systems. Proper documentation of these inspections and tests is essential to demonstrate compliance with the code. It is also important to train personnel on the proper operation of these systems. This includes training them on how to activate the EPO, how to shut down the electronic equipment and HVAC systems, and how to verify that the fire suppression systems have activated. Regular drills and exercises can help to reinforce this training and ensure that personnel are prepared to respond effectively in an emergency. Consider a scenario where a fire breaks out in a computer room. The first thing that should happen is that someone activates the EPO. This will immediately shut down all of the electronic equipment in the room, reducing the risk of electrical shock and preventing further damage to the equipment. Simultaneously, the activation of the EPO will trigger the pre-action fire suppression system, which will release water into the sprinkler piping. If the fire continues to grow, the heat from the fire will activate the sprinkler heads, which will then release water onto the fire. In addition, the activation of the EPO will also trigger the ANSUL system, which will release a chemical agent onto the fire. The chemical agent will quickly extinguish the fire, preventing it from spreading to other areas. This coordinated response will minimize the damage from the fire and protect the lives of the occupants. Without the interlock between the EPO and the fire suppression systems, the fire could spread rapidly, causing significant damage and potentially endangering lives. In conclusion, the interlock between the EPO and the pre-action and ANSUL systems is a critical requirement of NFPA 645. This interlock ensures that in an emergency situation, the fire suppression systems are automatically activated, providing an immediate and coordinated response to a fire. This helps to minimize damage, protect lives, and ensure the safety of the facility. Understanding and implementing this requirement is essential for compliance with NFPA 645 and for protecting the facility from the devastating effects of fire. Compliance with NFPA 645 involves meticulous attention to detail in design, installation, and maintenance. For example, the selection of appropriate disconnecting means is crucial. These devices must be rated for the specific voltage and current requirements of the equipment they serve. Furthermore, they should be easily accessible and clearly labeled to ensure that they can be quickly located and operated during an emergency. The design of the interlock system between the EPO and the fire suppression systems requires careful consideration of reliability and safety. The system should be designed to minimize the risk of false activations, which could disrupt operations and cause unnecessary damage. At the same time, it must be designed to ensure that the fire suppression systems will activate reliably in the event of a fire. This often involves the use of redundant components and fail-safe mechanisms. Regular testing and maintenance are essential to ensure that the systems continue to function correctly over time. This includes periodic inspections of the disconnecting means, testing of the interlock system, and verification of the proper operation of the fire suppression systems. Any deficiencies identified during these inspections should be promptly corrected. Training is another important aspect of compliance with NFPA 645. All personnel who may be involved in operating or maintaining these systems should receive thorough training on their proper use and function. This includes training on how to activate the EPO, how to shut down the electronic equipment and HVAC systems, and how to verify that the fire suppression systems have activated. Regular drills and exercises can help to reinforce this training and ensure that personnel are prepared to respond effectively in an emergency. NFPA 645 is a comprehensive standard that addresses many aspects of fire protection for electronic equipment. It is important to consult the full text of the standard to ensure that all applicable requirements are met. The standard is updated periodically to reflect changes in technology and best practices, so it is important to stay current with the latest edition. In addition to NFPA 645, other codes and standards may also apply depending on the specific application. These may include the National Electrical Code, the International Building Code, and other local codes and regulations. It is important to consult with qualified professionals to ensure that all applicable requirements are met. By following these guidelines, facilities can effectively protect themselves from the risks of fire and ensure the safety of their occupants. The benefits of compliance with NFPA 645 extend beyond fire protection. Proper design, installation, and maintenance of these systems can also improve the reliability and uptime of electronic equipment, reduce the risk of electrical hazards, and enhance the overall safety and security of the facility. Furthermore, compliance with NFPA 645 can help to reduce insurance costs and avoid potential liability issues. In summary, NFPA 645 provides a comprehensive framework for fire protection in electronic equipment areas. By understanding and implementing the requirements of this standard, facilities can effectively protect themselves from the risks of fire and ensure the safety of their occupants. The interlock requirement discussed here is just one aspect of this standard, but it is a critical one that can have a significant impact on the effectiveness of fire protection.